Hello, dear aspirants. This is Dr. Saurav Source class. Our contact number is 9836793076. Again, I am repeating that 9836793076. And our email ID is sauravsurclasses@gmail.com. So please feel free to contact via these contact details so we can arrange one-on-one classes and you can join our regular batches. So we will provide you all the helps you will need in your all exams preparations like our TIFR GS, NVHM, ISI, CMI, etc. So please feel free to contact via these contact details. Okay. So now we are going to solve a problem which is a true false problem that is appeared in our TIFR GS 2025 question paper. So the question is so that statement is if our f be a function which is from f to f is a homomorphism of fields, then our f is surjective. Okay, so we have to find that any field homomorphism is surjective or not. Okay, so we can do one thing, that what is our field homomorphism. So we know that our f from f to f be a field homomorphism when three things occurs. And again one thing, yeah, x y belongs to f, then three thing occurs. That first thing is my f of f plus y is fx plus fy. We all know that. And after that, the second property is my f of xy be fx into our fy. And the third property is my f of 1 is equals to 1, while and then our f of 0 is equals to 0. So now we have to think about the other things. So now we can say that any field homomorphism will might be injective. Why? As we can take that our f can be what? So we have to think about the kernel also. So our kernel of f only can be f itself and singleton 0, as our f is the field. Okay, so as our f is field, so our kernel can be this and this, but our kernel cannot be this whole f, because our f of 1 is equals to 1, that is not equals to 0. So our as we are getting a term which is not in which cannot be f of 1 is equals to 0, so f of x is equals to 0, so our f cannot be the kernel. So the kernel is only my singleton 0. So we know that if our kernel is only singleton 0, then the function or the homomorphism or everything will be injective. So my any homomorphism of fields from field to field is always injective. So now I am going to tell about something. Sorry, we are going to tell about these things. Metal. I want to tell that. Okay, so we have to check it is surjective or not. So that is not entirely correct, because a homomorphism of fields is indeed injective, but it's not necessarily surjective. So we are going to give you a counter example. Okay. Okay. So if we take a homomorphism, field homomorphism from Q to Qi, that means the Q is the field of the rational numbers and Qi is the field of the Gaussian rationals. We know that. So the F is a homomorphism of fields, but it's not surjective since our I is not belonging to image of F. However, it's true that if yeah. So if our f is a homomorphism from f to f dash is a homomorphism of fields, and our f dash is a finite field, then it is surjective. If they told us that that this is finite, then it will be surjective. But they told us that this is not finite, so we have an counter example that is countered by this. And another thing we can tell that, was as if it is algebraically closed, then it will also be surjective. As we take the as we take it by the complex number, we'll see, then it will happen. But as they told, as they are not told anything, so our this statement will be false here. Yeah. So hope you understood. And again, I am telling that please feel free to contact us via these contact details, so we can arrange doubt clearing sessions and regular classes that will help you with your question solving. Okay.